Starting the recording again. Okay. So, good evening, everyone, and I hope you had a great weekend. So, what I'm going to do today is I'll start uh, the actual computer network, not computer networks, I'm sorry, CCNA classes. And today in the last class, we saw about what is computer networks and what are the things that we will be going through in the computer networks. Also, we saw about the TCP IP layer in the uh, last session. So today we'll start with the major part, going with the physical layer as well as the data, a part of the data link layer as well. So I'll start sharing my screen, and once you see the screen, just let me know. So do you see the screen?
Yes, yes.
All right. Thank you.
Yes, yes.
Fine. So in our last class, as I was saying, we went through the TCP IP model, starting from the data link layer, where we saw about the cable, and then we went with the data link layer, the layer 2, where we saw how VLANs were created, why VLANs were created, and what was the need to create a VLAN. And then we went to the network layer, or the third layer, where we saw what is IP and how do we correlate the IP with the real-time scenarios like roads, vehicles, etc. And then we went to the transport layer, that is the layer 4, and we saw how the transport layer is helping our devices to get an acknowledgement from source to destination, and we saw this using an example of our WhatsApp messages. And then we saw about the application layer, where we saw how when we enter google.com, what is basically happening behind, right? So we all saw that. So today I'll start with the first layer, that is the data link, the physical layer, and there's nothing much in it. So we'll quickly finish off the physical layer, and then we'll start the data link layer. All right. So, so as you see here, this typically is your very basic connectivity that you will always see. Where, for example, if you see here, there are multiple PCs that are connected. There you can see this is a PC, this is a PC, this is a printer, and this is a PC. So usually you will see this in a very small office. Okay, it is called as small office. Okay, usually you will see this in very small offices where very few users are there, and they need a connectivity. So what you will see is that the PC would be connected with an Ethernet cable to a nearby switch, and that switch will then be connected to a router. This router you will not be able to see because this will be connected somewhere outside the building, and this router will then be connected to the internet. So this is how a typical uh, connectivity looks like. Okay, and instead of this, you would have seen something like this in your home. Okay, where this is your Wi-Fi router, or in networking we call this as access point, and your Wi-Fi router is basically sending signals to your mobile phones or wireless devices, and your wireless devices are also connected to this access point. Now what happens is that this Wi-Fi router is connected with an Ethernet link to a switch. This switch again you will not be able to see. Okay, and this switch will then be again connected to multiple other PCs or networking devices in the area, and again the switch will be connected to a router which will take you to the internet. And if you remember, we spoke about internet in our last class, where internet means interconnection of different networks. So you will be able to reach different servers like Google, Yahoo, or YouTube servers, and you can access the internet. So this is typically how your home network would look like. Okay. And if we go to a bigger room or bigger environment, for example, your office, you're sitting in your office, and how would that usually look like? You will see that your laptop or your PC is connected via two methods. If you're using a laptop, you can connect it with an Ethernet cable, or you can connect it with your Wi-Fi adapter. So in both the cases, your Wi-Fi adapter would be connected to a nearest access point or the Wi-Fi router, and that Wi-Fi router would be connected to a nearest switch. So as in this diagram, you can see there are different floors: first floor, second floor, and third floor. And all these floors will have similar connectivity where different users will be connected to the nearest switch in your floor. And all these switches on different floors will then be connected to a bigger switch. This switch is called as a distribution switch. Basically, it is trying to distribute the network or connectivity to different switches on different floors or different area. Okay, and all these nearby switches, okay, these switches, as in the diagram, switch 1, switch 2, and switch 3, they are called as access switches. Okay, now to remember what is the difference between a distribution switch and an access switch is a mnemonic that I created. Not created, I usually use. So access, an access switch or an access device lets you access the internet. That is the first step of access to the internet. So all your PCs will be connected to a switch. This switch gives you an access to go beyond itself. That is why it's called as an access switch. You can think like this. Then all these access switches are connected to one single distribution switch. Okay. Then this distribution switch is connected to a nearby router, and this router takes you to the internet. This is basically how your enterprise network or a connectivity in your apartment, in your building would look like. Even in your office, you would see such a connectivity in your network. Uh, the physically what you can see is only this. Physically, when you're sitting on your laptop in your office cubicle, probably you will see the connectivity only up to this. Your laptop is connected to your Wi-Fi router, and then your Wi-Fi router will be connected to a switch. This connectivity or this connectivity or even this connectivity is not physically visible to you, but they are present there. Okay, someone has raised their hand. Yes, Prashant, please go ahead.
Yeah, good evening, sir.
Good
Sir,
evening.
I have a question here. Our router is connected to distribution switch, and then we have our access switch. So, my question is, shall we connect the router directly from the access switch, not from the distribution switch? Is it possible?
It is possible. Yes, that is what we saw here. If you see, this is what we saw here. Usually
Yes, but
this, yeah. So what happens when your office is pretty small? Okay, where you have only very few users, like this one
mm,
here. When you have only few users connected, you can directly connect your router to a switch. That is also possible.
fine. But in case if we have a distribution switch, then in that case, I am asking,
Hmm.
can we directly connect the router to the access switch?
I did not get your question. Sorry.
Yeah. Uh, So my question is like we have distribution switch and then we have a access switch. Okay,
Correct.
fine.
Yes.
And we want to connect our router directly to the access switch, not with the distribution switch, not following the distribution switch.
Okay. Hmm.
Connection. Yeah, is the question. Yeah, right.
Okay, yes, you can do that. That's no problem. The reason is you need a distribution switch. For example, see, switch has some capacity. Okay, a particular switch. Okay, a particular switch here will have only limited number of ports. or interfaces that it can connect to. So for in this example, it only has 8 ports. Okay, so if you connect 8 different devices, okay, and one of this is connected to the router, okay, but you need 16 devices to be connected, what will you do? Okay, so basically then what happens, what you will do is you will connect all these interfaces to a PC, okay, and one of the interface will go to another switch. This switch will have a few more interfaces or ports, and then these switch interfaces will be connected to PCs or any other devices there. Okay, but then what happens is that you need distribution when see, distribution is just a name. It is just a name given to that switch, because uh, a switch has limited number of ports. Okay, you cannot connect 100 devices to a switch, you cannot connect 1,000 devices to a switch. Okay, so you need connectivity from one switch to another switch to third switch, fourth switch, fifth switch, in order to expand your network. So the nearest device, the nearest switch connected to a router is called as a distribution switch. It's just a name given to it. You can connect it here, you can directly connect here to here, but then you will you can connect only those devices that will have connectivity to this switch. If you want more switches, then you need an extra device, extra switch, so that that is distributed. We'll see that in some point.
Okay, thank you, sir.
Okay, now, so as I was saying, all these are connected through Ethernet switches, sorry, Ethernet links, Ethernet. So what is this Ethernet? Okay, basically Ethernet is a standard name given by IEEE. Okay, I am pretty sure you would have heard about IEEE formats, IEEE standards in your colleges. So what happens is that these IEEE organization is the one who gives the name to all these wires, all the wires that are created, how two devices should be connected, what wires should you use, should you use an Ethernet copper wire or should you use a fiber cable. All that thing is basically standardized or put down. The policies are put down by an organization called IEEE. Okay, so IEEE basically gives or differentiates. Uh, Basically, there are two types of wires. One is a base T wire. The other is a base X wire. T wire means those wires are made of copper wires. Okay, base X means they are made of optical fibers. So basically, copper wire carries electrical signals and your optical cable carries light signals. This is the major difference. So if you see here, there's a table given where there are different standards. So 10 base T means the speed on that particular copper wire is 10 Mbps. It's a copper cable because the last word or the last letter is T. And you can also see the length of each of these wires. Then you have 100 base T. It means the speed is 100 Mbps and the length is 100 meters. That means the length of this wire is 100 meters. So two devices who are 100 meters apart can be connected with them. The next is 1000 Mbps, 1000 Mbps, sorry, the name is 1000 base LX. It is a fiber cable, 1000 base LX, and it can go up to 5,000 meters. That is 5 kilometers, right? So it can go up to those things. So basically IEEE gives the format, also gives the standard, also put down the rules of creating a wire or no, yeah, creating a wire and how these wires should basically work. So this is one of the tables, and based on their names, you can guess the speed, and you can also guess if it's a copper wire or if it's a fiber cable, optical wire. Okay, so this is one of the cablings or how usually your wires carry information, how your wires carry information from one end to the other end. Okay, so this is one of the copper cables. Okay, we call it as unshielded twisted pair cable. Unshielded, there is no shield. Unshielded twisted pair. Okay, so this is just an overview or very simplified view of how two devices are connected using a copper wire. Okay, so when I say untwisted pair, when I say untwisted pair, sorry, not untwisted, twisted pair. When I say twisted pair, pair means there should be two wires, right? There should be two wires. Okay, there is one wire which basically transmits, the other wire which basically receives an information. So if there are two devices, node 1 and node 2, as per this diagram, one of the wires in the pair will transmit the traffic, the other wire will receive the traffic. This is what a twisted pair cable usually does. Okay, so if we just take this into a more or wider view, how will this look like is this one. So imagine that you have a node. This is node 1 and this is node 2. Okay, just do not worry about these ports. We'll understand these ports in a few moments. Okay, so what happens is that this is your cable. Only this part is your cable. Okay, and this cable is then on both the ends connected to a connector. It ends with a connector. In this example, I'm taking an RJ45 connector. Okay, and then this RJ45 connector, okay, is connected to an RJ45 port on the device. Okay, so just for your information, how will this look like is, if you have an Ethernet port on your laptop, okay, Ethernet port on your laptop, you connect a wire into it. Okay, you connect a wire into it. When you connect a wire in your Ethernet port, it gives a click sound, right? It gives a click sound. That clicking sound is created by your connector here. Okay, this is the connector here, and then your wire starts. Usually your wire would be in a blue color, right? So in order to understand this, we'll understand it here. Okay, so this is how your typical RJ45 connector would look like. Obviously you will have seen these wires in your computer lab or office, wherever you are working. So your wire basically ends here. Your wire ends at this end, and this end is then connected to an RJ45 connector. Okay, then this RJ45 connector has to be inserted into your network interface card of your switch or router or your device, whatever. Okay, so once again, let me tell you that when you buy a device, okay, if you're buying a switch, if you're buying a router, okay, until and unless you have an interface card, network interface card mentioned here, you will not be able to insert any wire into it because it's empty. When you buy a switch or a router, a new switch or a new router, it's an empty box. It's an empty box. You will not have these connectors. You will have to buy these connectors again. So until and unless you have these connectors, you will not be able to insert this particular RJ45 into the port here like this. Okay. Any question? I think someone raised their hand, right? Uh,
Hi. You just mentioned that there'll be no like when we buy switch or router,
hmm.
there'll be no port, right? We but there will be NICard already in the board, right?
Okay, in some devices, like small devices like this one, where you see this is a very small switch.
Uh-huh.
Okay, someone mentioned they're not able to see the screen. Can you guys, everyone else, can you see the screen?
I
Yes,
can.
sir.
Okay, uh, give me a minute. Okay, can someone, Rahul Rajput, this is second lecture, not a third lecture. This is second lecture. The first lecture was done on, I think, Thursday or Friday, if I'm not sure. It was done on Thursday and it was an introductory session. Anyway, so as I was saying, okay, someone asked me a question. Can you tell me your name?
My name is Suma.
Suma. All right.
Yes.
So, Suma, what happens is that for smaller devices like this, okay, the NIC card is always there. But if we go to a very big chassis, okay, which has multiple racks, okay, like server devices or bigger routers or bigger switches, you will not have these. This is how their business works. Okay, you need to buy a card, you need to buy a line card, you need to insert that line card over here, and then in the line card you need to insert these NIC cards, and then only you can connect these wires. So for small switches, small routers, you will have the NIC card present. But if you, when you go to a bigger switch which has bigger processing capacity or a better processing capacity, you will not see a NIC card there. It will be an empty chassis. Basically, like you're buying a car which does not have a seat, which does not have a tire, does not have a steering wheel, nothing. It's just a box. You need to buy the chair, you need to buy the seats, you need to buy the seat belts, everything. So it's like that.
Okay, so if I'm buying Switch means I just have to like buy, like, I mean rest of the things will be there. I have to buy the one NIC card. Like if like it's a big device, so we have to buy the NIC card separately.
Correct.
Okay. And one more question, like the maximum number of, what is the maximum number of ports in the Switch which is available? Right.
It depends on model to model. It
Okay.
depends on model to model. For example, it's like, uh, let me give an example. Tata Nano. Okay.
Okay.
It's a very small car.
Okay.
Okay. Since it's a small car, it has small sitting capacity. It has very limited features. Okay. Then let's go to an SUV, Fortuner. Right. Fortuner is a big car. You the seating capacity is more. Okay. You have more features. Similarly, with your switch, okay, it depends on the model, it depends on the type, it depends on your use also, and the number of ports.
Dependency user also.
Sorry?
Dependency user also. How many users in there in one
Yes, it
branch or
depends on the
one
user
company?
also. It depends on the user also. Exactly.
Yes.
Okay. I'll request to please hold on to your questions in the end. Okay, because the time is
Okay.
will move on. Okay. So
Sure, sir.
yeah, no problem, no problem. So this is one, and I hope you understood what this is about. Then
No, sir. फिर से explain
yeah,
करें?
yeah. Any questions with regarding this? Someone had raised a question regarding this.
Oh,
Sir,
what
एक
about
बार
this
repeat
maximum
करो ना,
length,
sir.
like copper 100 m, copper 100 m, like that you have mentioned of.
Yeah, yeah.
So this is a capacity of that means that much kilometer it will go like that. What
I
I
mean, that
didn't
is the length of the wire.
length of the wire. Okay,
Yeah,
okay.
length of the wire
And
plus.
not a signal strength, no?
No, 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 no.
Okay, okay.
Okay, that's the length of the wire.
Because is sometime the fiber is taking some 500 meter or 1 kilometer, 2 kilometer, 10 kilometer like that. So at that time
Correct,
that signal strength will be very no.
correct,
So
correct.
how they will
This
calculate?
length that I'm mentioned is the length of the wire.
Okay, okay.
Okay, this is the length of the wire. Any question with this? Because next we'll move on to the optical cable only. Okay, because with optical cable you will have better speed, you will have more distance. So if you can see here, okay, you have different cable standards, and based on their, if you can see, this is all 10 gigabit speed. There are This is all 10 gigabits per second. Their speed is 10 gigabit speed, 10 gig, 10 gig, 10 gig, but their distance vary. The maximum distance that they can go up to is 400 meter, 300 meter. This is 10 kilometers. This is 30 kilometers. Okay. So if we check, I don't have to explain all this. This is very common. You would have learned this in your college days. So this is how your copper, so not copper, optical fiber looks like. It has multiple layers, so that and that is why they are shielded. It's more secure, but then they are also costly. So you can send signals based on your. You can send signals as an LED or proper light, or you can send them as a laser also, right? And your one end will change your values, like binary values, ones and zeros, into light or electrical signals, and the other end will change it back to the light from into your binary signals. Okay. So I'm not going much into this because you've already learned this in your college about this diagram specifically. Okay, and this is their distance. Any question with this cabling?
What is the cable type, Laksh? The SM in the optic fiber optic multi-mode, and what is the SM?
Yeah, multi-mode and single mode. Basically, this is multi-mode, meaning you can send multiple light signals. Okay, in your LED lights, you can send multiple light signals, but single mode, this is laser. Okay, you can send only one single light signal. That is your, like, laser is just one single light, right? But in your LED lights has multiple light photons, right? So you can use multiple signals. That is what you call as multi-mode. Laser is just one single photon, light photon, and you can send only one one signal, right? So that is what is MM and SM. MM means multi-mode. SM is single mode.
Got it. Thanks.
Okay. Moving on. Okay. Now is the interesting part. So we saw a physical layer about how wires are connected into your switches. Now what we are going to see is, okay, one more thing, please mute yourself, right? All of you, please mute yourself. Now, what we are going into is the second layer, or what we call it as data link layer. Okay. So as we were seeing here is that two devices, or specifically the switches. Okay, when we are moving from physical layer into the second layer or the data link layer, any networking device will read a data link layer information, and those information contains these fields. Okay, those information contains these fields. Typically, this is your Ethernet header. Okay, now what is an header? Ethernet header. Okay, so it's like you are writing a letter. Okay, when you write a letter, there is a format to write a letter. Okay, so you write the to address, then you write the from address, then you write the subject. Here you write the date. Then this is the body of the letter, and then you give your signature, right? So this is one of the formats to write a letter. Without any of these information, the letter is incomplete. Okay, the letter is basically incomplete. Similarly, when a networking device is reading any information in your layer 2, it has to read all this information present in layer 2. Any of this information is not present, then your layer 2 format is basically incomplete, and your networking device will not be able to understand that particular information. I hope I was clear. I'll repeat again. When in layer 2, when your device basically converts your electrical pulse or light pulse into a binary format, the first thing it reads is your second layer information, and or what to say, a data link layer information. And that data link layer information has a particular format, and that format is on your screen. If any of this field in that format is missing, your networking device will not be able to read the information or complete that particular information what your device is sending. Okay, so we'll go one by one into these layers. So please pay a very uh, please pay attention here. So the first field here, okay, the first field is preamble and SFD. These two are the first two fields, and these are basically bytes. So there is a 7 bytes of preamble field, and you have a 1 byte of SFD field. Okay, what is SFD? SFD says start frame delimiter. Start frame delimiter. Okay, so what is a start frame delimiter and what is a preamble field? Basically, they are telling any networking device that a new frame is about to start. That is the work of a start frame delimiter and a preamble. Start frame delimiter tells a new frame is about to start, and the new frame is starting with a destination MAC address header. Okay, a destination MAC address header. So your preamble and your start frame delimiter tells any networking device that a new frame is incoming. That is the work of preamble and SFD. Now, 7 bytes. Let me go into one of the bytes. This is 1 byte. Okay, the format of your 1 byte in preamble is 10101010. So 1 byte is equals to 8 bits, right? So these are 8 bits of 1 byte in your preamble. So you have similarly a 7 such bytes in preamble. So you have 56 bits of alternate ones and zeros. You have 56 bits of alternate ones and zeros in your preamble field. Okay, then what happens is that the next bit after your 56 bits are over, your SFD field starts. The SFD field is just 1 byte. Okay, and that field also looks very similar. 101010. These are 7 bits. The last bit, instead of being a 0, this is 1. Okay, instead of being a 0, it is 1. 10101011. So in total, 7 plus 1, you have 8 bytes. So that gives us 64 bits, right? Out of these 64 bits, 63 bits are 10s, 10s, 1010 continuous ones and zeros. The 64th bit is 1. Okay, so visually if I have to tell you, just imagine this. You have two switches, switch 1, okay, and switch 2. These two switches are continuously sending information. They are continuously sending information. Okay, so let's say that this is information number 1, 2, 3, 4, 5, and 6. Okay, please, Asif, please mute yourself. So you have okay, let me. Thank you. So all of them, switch 1 and switch 2 is sending information continuously. So just think of my problem. Switch 1 has sent 5 messages all together. Okay, now I am switch 2 or you guys are switch 2. Just imagine your problem. The problem is all these messages, message number 1, 2, 3, 4, and 5, all of them have the same format. All of them have the same format. So how will I differentiate message number 1 from message number 2, or message number 2 from 3 or 4 or 5? How will I differentiate message number 1 is different, message number 2 is different, 3 is different, 4 is different, 5 is different? Because all of them have the same information. All of them have preamble field, SFD field, destination, source, type, data and pad, and FCS field. How will I differentiate? 1 is different, 2 is different. That differentiation is given by preamble and SFD field. Because of them, the switch knows that let's say that message number 1 is read. Message number 1 is finished reading. The last information that switch 2 read in message number 1 was FCS. After FCS is over, okay, suddenly there are 64 bits of ones and zeros, alternate ones and zeros. So once the switch 2 reads 64 bits of ones and zeros, it understands that message number 2 is starting. Message number 2 is starting. Message number 2 is starting, and I will read the destination, source, type, data, and FCS. Once the FCS of message number 2 is over, then again it will start reading 64 bits of ones and zeros of message number 3. Those 64 bits of ones and zeros are the preamble and SFD field of your message number 3. The message number 3 will end with FCS. Once this FCS is over, again 64 bits of ones and zeros will start. Okay, so switch 2, or I will understand that the preamble and SFD field have started. Now a new information is about to come. That new information will be again a destination, source, type, data, and pad of message number 4. So this is how any networking device will differentiate between two different messages in your layer 2. Okay, any question?
Yes, sir.
Yes.
Sir, I'm not getting your point. Please repeat that again.
Okay.
What is a preamble and what is SFTP? Sir, through the MAC address, we can find out now which masses are coming. Which masses 1, masses 2, and masses 3, masses 4. So through the MAC address, we can verify, no?
No.
Okay.
Just imagine this is switch 1, this is switch 2. Okay, since you have brought up MAC address, let's say that the MAC address of switch 1 is 1111. Okay, this is 2222. Okay, and switch 1 is sending message number 1, 2, 3, and 4. All of them will have the same MAC address, destination MAC and source MAC. How will switch 2 differentiate?
Okay.
Got my point?
Yeah, I'm getting the point. And what is preamble? How to preamble work, sir?
Let me put this here. Okay, then again. So just imagine this is how your messages are coming. So I have switch number 1 sitting here and switch number 2 sitting here. Okay, and switch 1 is continuously sending 4 messages to switch 2, right? So all of them will have the same information. If you see here, if you visually see here, all of them have the same information. So how will switch to differentiate that this is message number 1, this is message number 2, this is 3, and this is 4. Switch to differentiate it with the help of your preamble and SFD field, because your preamble and SFD field are one alternate ones and zeros all together. Okay, so once switch to finish reading the FCS field of message number 1, preamble field of message number 2 will start, which will have alternate ones and zeros, 63 alternate ones and zeros, and the 64th bit will be a 1. Okay, so then message number 2's FCS is finished reading. Message number 3's preamble and SFD will start. Switch 2 will know that a new message is now I am going to read a new message. Then it reads the FCS field. When the FCS field is over, message number 4's preamble and SFD field will start. So switch 2 will understand that a new message is now incoming. So this is the purpose of your preamble and SFD field, basically to tell the switch that a new message is incoming. A new message is incoming, and the new message will start with a destination MAC address. Everywhere, the new message starts with a destination MAC address. I hope this was clear.
But there is a no collision domain, sir.
I'm not come into that part, right? I'm just explaining the Ethernet header.
This is the standard format for that.
Yes, this is the standard format of all your layer 2 header. Let me show you on a Wireshark. So right now I am running Zoom session. Okay. I'm running Zoom session. So in your Wireshark, it does not capture all the fields, but it does capture few fields. Okay, so if you see here, this is a standard format. In Wireshark, you cannot capture, you will not see the preamble field, you will not see your SFD field. But just to give you a hint, if this is how if you see here, if this is how your datas are being exchanged, if you see, all of them are hexadecimal format. Okay, 000102030 FA A47507 2E6B. These are continuously being sent. How will switch understand that? Let's say that this one, this is one message, this is another message, this is third message, this is fourth message. How will two devices understand one message from other message? That differentiation is done by your SFD and preamble field.
Okay, sir.
I hope this made it very clear.
Sir, yes.
Can you please repeat that once again?
Okay, which one? Where are you confused?
Hexadecimal sign you showed, no, just before.
So I was saying this is just an example. If you see here, if you read this hexadecimal messages, this is all data. All this is data. Okay. So FA A47507 2E6B 70 B6 all are data. So how will switch 1 understand that one message is over, the other message is starting, a new message is starting, a new data is starting? Okay, so there should be some value, or there should be some format that the switch will understand that the old message is over, the new message is incoming. I'm going to read a new message. Okay, I have done reading the old message. Now I am going to start reading a new message. That differentiation, that bifurcation is done by your preamble and SFD field. So, okay, then moving on, your destination. These two are your MAC addresses. Okay, now MAC addresses you would have already seen. Let me show you here. Your MAC address looks something like this. FA A47507 2E6B. This is your format of a MAC address. This is a 6-byte field. This is a 6-byte field, basically 48 bits. Your destination MAC address and source MAC address both are 48 bits field. Based on your MAC address, any networking device will forward your data. How will switch forward the data? We'll study that later. Okay, but a MAC address is like just a unique address, just like our house address. MAC address is a very unique address, and it is very unique to all your networking device. Okay, and this MAC address is basically distributed or created by an organization. I forgot the full form. The organization name is OUI. Okay, I forgot the organization's name. Sorry. So they give the MAC address, and this is how your MAC address should start with. Okay, so here if you see F4A 475, this these 3 octets were given by the organization OUI. The rest of them is given by the manufacturer of that particular networking device. So for example, Lenovo, I am using a Lenovo device. So OUI has said that I should start the MAC address from F4A475. The rest you have to look into it. So Lenovo decided that it will start the MAC address from F4A475. Then it decided that it will give the MAC address 072E6B to my laptop. This is how your MAC addresses are basically assigned and made sure that your MAC address across the world remains unique. Why should they be unique? We will understand in the next class. Being unique is also a very important feature. Okay, the next field you will see is the type field. Okay.
Laksh, sorry to interrupt. Before going on to the type field, I have one question. So here the destination and source means the switch 1 and switch 2, or it's a different terminology?
Okay, so in this one I have not gone into how MAC addresses are being exchanged or how MAC addresses are gone through. So just think that for now, just think this destination is like switch 1, okay, or switch 2 here, and there is a PC connected. Okay, or let's not go over there. PC2 connected here. This is PC1 and this is PC2. Okay, so when we are talking about destination MAC and source MAC, I'm assuming PC1 is trying to communicate with PC2. Okay, PC1 is trying to communicate with PC2, saying that my MAC address is 1111. 2222 is, when I'm saying 2222, it means 22 here, 22,
Yeah,
then 22, 22, like that.
Yeah.
Okay, and this is all one. So when I'm saying destination MAC and source MAC, I'm saying when PC1 wants to talk to PC2, the destination MAC address here will be 2222, source MAC will be 1111. Okay, I'm not gone into much detail as to in Wireshark what is this destination MAC address and source MAC address. That is our later topic. Okay.
Okay.
So next, moving on to the type field. What is this type field? As you remember in our first class, when I said I was talking about something called as encapsulation, right? Encapsulation means your higher layer. Okay, higher layer is basically, sorry, pardon my handwriting. Higher layer is basically covered by a lower layer. Okay, so in this example, layer 3 will be encapsulated by layer 2. Okay, is encapsulated by layer 2. Now, when any device is reading this layer 2 information, it reads something called as the type field. When it reads the type field, it gets to know, it gets a warning, or it gets an notification what information is it going to read in your layer 3. The type or the protocol that it is carrying in the layer 3, that information is present in your type field. So let's go back to our Wireshark. So if you see here, this says type field. In the type field, it says IPv4. So IPv4 is a layer 3 information. So basically, your type field in your layer 2 header says what kind of layer 3 information is it carrying. Okay, so in today's world, this basically would be either an IPv4 information or it will be an IPv6 information. Okay, so your type field tells what kind of layer 3 information is it carrying, and where is it carrying, and how is it carrying. It is carrying in this data field. This data field contains all your information starting from layer 3 up till layer 7. Okay, this data carries all that information, but your type field only tells what kind of layer 3 information is it carrying. All right. Next, the last field, that is FCS. FCS means frame check sequence. Frame check sequence. Now, what is a frame check sequence? So basically, frame check sequence, if you just look at the name, it just says it it basically checks the sequence of your frame. It basically checks the sequence of your frame. Okay, you will get an idea when you read the name itself. So why is there a need for a check? So if switch 1, okay, PC1 is sending some information, okay, and this is PC2. So what happens is that in your frame check sequence, what happens? PC1 runs an algorithm. Okay, I'm not sure what algorithm it runs. It runs some kind of an algorithm and it comes with some value. For example, that value is ABC. For example, hypothetically, I'm saying that value is ABC. Now, when this frame reaches PC number 2, it also has to run the frame check sequence with the same algorithm. Okay, when this algorithm is run on PC number 2, that value should also be ABC. When these two values are same, PC2 will understand that your layer 2 or this whole Ethernet frame is secure, is safe, is not corrupted, is not corrupt. All this thing is made sure by your FCS header in your Ethernet frame. Any question regarding frame check sequence? Okay, I'm not sure what algorithm it runs, how do they define the algorithm, but this is the work of your FCS. Okay. Any question with this frame, Ethernet frame now?
Yes, sir.
Yes, tell me.
Sir, it makes sure it is like FCS is making sure that that data is secure, safe, and not corrupt.
Correct.
Is it about the data which is going to exchange?
Not only the data, it is basically checking this thing, your destination MAC source type field. Okay, and your also not the data. It can also check the data also. It can also check your data if that is correct, because the moment your FCS number changes, okay, the moment if say here it is ABC, okay, and on switch to the FCS value comes to DEF, for example, okay, it is not going to accept this packet. It is not going to open this packet, basically open this data. When it opens the data, it will start reading your layer 3 information. Okay, so basically your FCS is telling either to open the data information or should it not open the data information. So it is actually not just, it is basically helping your device. It can be a PC, it can be a router, it can be your mobile laptop or anything. Basically, it is telling either to open the data or and read the layer 3 and not open it at all. So it is also checking your preamble, SFD, destination, source type. Before opening the data, it opens your FCS packet or FCS frame, or sorry, FCS field. When it opens your FCS field, it does the algorithm, it does the check, it finds out if your FCS on the source and destination is same or not. If it is same, then it opens your data field where it reads your layer 3 information. Clear?
It means it will recheck the frames from source to destination, whether it is both and is same or not. Then only it will
Correct.
open.
Correct. No, see, the thing is, your information is basically read from left to right. Okay. Preamble and SFD tells it is starting. The information is about to start. That's okay. Okay. There is nothing to be worried about. There is nothing to be security. There is no issue of security in this field for now. Second, the destination and source, destination MAC and source MAC. Okay. So where do I use the destination and source MAC? When it is checking the destination MAC, for example, switch 1 and switch 2, or PC1 and PC2. Let's imagine PC1 and PC2, not switch. You'll understand why I'm not writing switch. Okay, PC1 and PC2. Okay, so so PC2 will read the destination MAC address. It will understand this particular message is for me, and this message has come from some source MAC address. There is no issue of security there also. There is no issue of security there also. It's okay. Type field. Type field, the PC number 2 will know what kind of information is it about to read in the data. Data is where all your information either can be corrupt, it can be hacked, it can be done anything. So before reading or opening your data packet, it reads the FCS header. Okay, it reads the FCS header, and in the FCS header, it checks the algorithm, and it finds out if the FCS value on both end is okay or not. Once it is okay, then only it will read this data. If the FCS is not okay, it will completely drop this header. It will not open it. It will completely drop the header. Someone raise their hand. Okay, is this clear what FCS does? Okay, let me again correct. FCS does not check the whole field. Okay, FCS does not check the whole field because security is only inside your data. You need security, or you can either corrupt, you can tamper with the information inside this data field only. There is no need for so destination. There's no need for you to be secure in your destination and source. There is, but that is a separate subject that comes under security. Okay, which we are not currently looking at. Right. So this will talk about data. So you can still tamper your destination and source, but your main information that you can tamper or hamper or can be corrupt or safe, not secure is basically this field. So this field is supposed to be very important, and that importance or privacy or security is checked by this frame check sequence. Any question? Okay, all right. I take that as a no. Okay. Fine. So
Laksh, sorry to take a little longer to ask this question. I just have one question. Like now, the preamble, SFT, destination, source are there, right? You have mentioned some numbers. So those are the bytes. So those bytes are default. It's not going to change, right? Only the data bytes will be changing. Correct?
correct.
Okay. Thanks.
So this is basically a standard format. You cannot
Yeah.
change this.
Yeah. Understood.
Okay. So even if you there are many softwares or tools where you can create your data link or Ethernet header, okay, for testing purpose. When you're testing, you can create your own. You use some software tools which will help you create a layer 2 header where you will see these are already set. These are already set. You cannot create anything lesser than the value given, or you cannot create anything more than the value given.
Understood.
Okay. So if you do that, then what automatically, basically what happens, your Ethernet header is wrong.
Right.
When your Ethernet header is wrong, this frame check sequence will identify it anyway. Even if you send a wrong information, if any of these fields are either lesser or greater, this frame check sequence will identify it anyway, and it will drop it. Okay.
Understood. Yeah.
And moreover, when you are trying to create a header, Ethernet header, it's standard. You cannot create something lesser or more. So even if you try to create a false information, you have to create within the limit. If you're giving a wrong destination address, you have to give it of a 48 bits only or 6 bytes. You cannot give a wrong information of 47 bits, or you cannot give a wrong information of 49 bits. You have, even if you're giving a wrong information, that should be of 48 bits only, because that's the standard format. Clear?
Yeah. Clear. Perfect.
Okay. So we'll stop here, and tomorrow we'll start with how switches basically understands these information that we saw today. That is your Ethernet header. How do switches understand it, and how with the information present, how do they forward the information from one PC to the other PC or any other devices, router, or another switch. Okay. So any question I can take a question for another next 5 minutes. Any question? So someone raised their hand. Let me quickly check who raised their hand. Mrityunjay, yes. Mrityunjay, yes. Tell me a question.
Is this format will not change, this is a fixed format, like the
Yes,
preamble SFT.
yes, yes.
So
This
for
is
every,
format for every Ethernet layer. This format is fixed. The information or the uh, thing that will change is your data. This thing.
okay, okay,
Only this will change. The rest of the fields will remain the same.
yes, yes.
Okay. Manikandan, yes. Tell me.
No question, sir.
Okay. Suma.
Yeah, in access switch and distributed switch,
Hmm.
like, is there any physical difference we would know that by knowing it, it's a physical switch, I mean, it's a access switch or it's a distributed switch? Is there any difference?
Yes, you will see that. You will obviously see, because let me, if I can, I don't have a diagram here or a picture here, but yes, access switches, if you can see here, where is the diagram? Yeah, you can consider this as one of the access switch where it has less capability. Okay, so there's a limited ports, limited power, and the only thing it does is, what happens is, from one of the ports here, it will be connected to a router, or it will be connected to a distribution switch, and from these interfaces, it will be connected to different users, PCs or printers or servers or anything like that.
Okay.
So if it is a distribution switch, probably you will see a bigger switch. Okay, you might see another switch over here, or a rack that you see, or another chassis, or something like this. You will also see a switch or another rack below it. So there's a physical difference. Obviously, there is.
Okay, thank you.
Yeah.
Laksh,
In
when
our
you were
company,
saying, sorry, I'll shoot this question. So, Laksh, you were saying that when we buy a new switch, right? So it just comes with the chassis, and will there be power supply units available, or we'll have to buy it
Yeah,
separately?
yeah. Power supply all will be available. Let me show you one. It's not- I'm not sure if the image is clear for you guys. Okay, I'm not sure if the image is very clear for you guys. Even it's not clear for me. Okay, so basically what happens is that your when you buy a chassis, it would look something like this. Okay, you will have fan modules. This is something called as fan module. Okay, and each of these brackets that you see. Okay, each of these brackets. Let me use my pen. Okay, these are called as fan modules. Right, and all you see these small rectangles. Okay, these are called as line modules. Okay, and if you see, these are basically empty. I'm not sure if you're able to see it or understand. These are basically empty. Okay, you need to buy all these things, and it is also based on your requirement. Do you need all so many ports? If you do not need so many ports, you will just buy what you require. Okay, if you see here, these are different ports. Okay, these are basically empty. The slots are given, but these are basically empty. So this is how you usually see a chassis when you buy one.
Sir, is there any NIC card?
Uh, NIC card in this chassis, probably if it comes with your package, yes. If it comes with the package, you can buy. That's what I said. This is how they make business. Okay, yeah, it's like you buy just a empty car. Okay, if you want a seat, you buy a seat. If you want if you want two seats, you just buy two seats. There is no need for you to buy a back seat. If you are okay
Okay,
with
okay.
two seats, just buy two seats.
Okay, sir. Okay.
Okay, if you can like similarly, if you it depends on you. If so, similarly, if you want an AC, you give an AC inverter there. If you don't want an AC, you run without an AC. So it all depends on your use. You So basically, when bigger companies buy routers or switches, they buy with this purpose. They buy a big module, they buy a big chassis, okay, and they use only those interfaces or slots where they require. Okay, and as
Yeah.
their technology or as their network grows, they start buying more and more NIC cards.
NIC card is a physical card, no?
Physical card that I showed you here. This is an example.
Okay.
This is a NIC card. Okay.
Laksh, basically in our company we are using a RAD switch and fiber home switches. So if I want to grow means if I want more port means I will do that looping from one switch to another switch. So
Hmm.
is this we will call that that means this type of switch we call as distribution switch.
I think that is called as multi-chassis serial, something like that. You can do that. Um, you can also, I'm not sure if you call that a distribution. See, distribution switch is just a name given. Okay.
Okay.
So
Okay.
it's basically, as I was saying, let's imagine that if you call this switch as a distribution switch, you call this switch as a distribution switch, I will connect this to a router here. Okay, and then I will use all these ports to connect to different PCs or end devices. Okay, now after all these ports are occupied, and I found out that I got 10 more users. I have 10 users more. What can I do? I have to use one of these ports, connect to another switch.
Switch, yeah.
And that switch will have multiple ports. And then I can connect these 10 users here. Okay. So basically, as I was saying, then what happens? This switch will become a distribution switch for this one. Then this will become an access layer switch. This will become a distribution switch.
Got it. And what about that speed? Speed will be distributed to that switch also? Is this means same speed will be?
It depends on the wire that you use.
Okay.
It depends on the wire that we use.
Okay.
Yes. Okay. Prashant, yes. You have a question. So guys, we'll take questions for another 2 to 3 minutes, right? And then we'll close the call.
Yes.
Yes, Prashant,
Sir,
tell me.
my basic question is like, what is the basic difference, like we can say, in a distribution and a access switch? Like, we have a multiple access switches, like we have a 10 multiple access switches in an organization, and we are using one distribution switches to get that all access switches interconnected, right? So is there any difference of like switching? Like, is there any difference between access switch switching or that distribution switching?
No.
Like the switching of the data is higher in access switch, in distribution, lower in access switch.
Again, as I was saying, it depends on the model. So if you're using a higher processing distribution switch, okay, obviously the way it will process the data will be faster. Okay, so let's say that I'm using a 16 GB RAM computer. Okay, you are using an 8 GB RAM computer. Okay, so obviously my processing speed is faster. Okay, so similarly, even with your distribution switch, it depends on the kind of processing speed it has. Okay, I'm not going into the processing how processing speed is defined and all. It goes into the hardware level. I'm not going into that. So obviously, as I was saying, distribution switch, it's not necessary that it has to be a higher power distribution switch. It does all depend on your requirement. You can make the switch here that you see also as distribution switch. You can use the same switch here again, okay, and connect this and this to a router. So basically what happened, this becomes a distribution switch, but the processing speed of this switch and the processing speed of this switch remains the same. There's no difference there. If you want,
Okay,
you spend more money, you buy a better switch, the processing speed will be better.
Okay, right. Like suppose, sir, we have a end device is my server, and I am accessing the server. So is there any? It will be different, like in this, like I'm accessing my server from any computer or laptop. So it will be depend like on its speed कि हमने access switch से connect किया है या फिर distribution switch के through हम communicate कर रहे हैं.
Yes, so basically that if you are the field engineer, if you are the admin, you should know that if you are connecting, for example, as I was saying, you are using a 200 Mbps speed. Okay, you need a 200 Mbps speed. Okay, so for 200 Mbps of speed, RJ45 connector is not going to work. You need something else. You need a fiber optic cable. Okay, so you need if fiber optic cable has to be connected to this switch, okay, to this switch, this should have a fiber optic port. If it has a fiber optic port, then that means this switch is capable of processing that amount of data, that amount of speed. If it is not, you will not be able to. So it all depends on the physical cabling, your requirement, your data requirement, how much speed you want, how much speed you don't want, how many users are there. Based on the users also you buy the access switch. Okay, all that thing. It completely depends on your usage. Anyone else?
Yeah,
Suma, yes, tell
yeah.
me. So this is the last question we are taking. Thank
Yeah,
you.
this is the last question actually. We say like MAC address is physical address which is printed on the like board, right?
Hmm.
Which that MAC address is printed on this NIC card, right? I just want to confirm. Is it printed on the
Hmm.
NIC board? What exactly the MAC address, where it is printed? Because we every time we say that MAC address is a physical address, physical address, physical address. So where exactly it is?
Okay. I'm not sure if it is where it is printed on the board here in the diagram. I'm not sure where it is printed, but all your interfaces here, ports, different ports here, if you see here, all of them will have a different MAC address. All the devices that you connect to. Okay, your let's say that I have you have different USB ports on your laptop. All your USB ports will have a different MAC address. Okay, even your Wi-Fi adapter will have a MAC address. Your
Yeah.
Ethernet port has a MAC address. I'm not sure where it is printed on the NIC card because that is not the study that I have done before. But that is how that is where your MAC addresses are basically given
Okay.
to each and every interface.
Okay, when we say right IP to MAC translation resolution or MAC to IP resolution,
Hmm.
that like how exactly it will take the MAC address?
It takes the MAC address of your interface.
Yeah, interface. Like how it will detect that the MAC address is that like is it? I mean, yeah, that is how exactly it figures out.
Okay, so that is done using ARP. Okay,
Okay.
address resolution protocol. I have not gone here. That probably I should take this class tomorrow or day after tomorrow.
Okay.
We'll address this there.
Okay. Thank you.
All right. Okay, guys. Thank you. Thank you for your time, and we'll see you guys tomorrow.
Thank you.
Thank you so much, sir.
Thank you. Thank you.
Good
Bye.
night.
Yeah. Good night.
Thank you.
Thank you, sir. Thank you.
Thank you for the class of today.
Thank you.
Thank you, Laksh.
Thank you.